So our next speaker is Luke Rainville.
Yeah, we're switching a little bit. The next three talks have a slightly different focus that we've been talking about. We're more looking at the gateway. So here I'm going to present a long time series. For the last 5 years, we've been sampling the water near Sri Lanka to really look at the exchange of the water mass, the different water masses that come in and out of the Bay of Bengal. And Luca and Uwe will also talk about different components of these collaborations, done mostly with our partners at NARA in Sri Lanka. So I don't really have to go through this too much, but this is just a picture of the northeast monsoon and southwest monsoon. And the interesting part here is that if you look at the black lines on these plots, these are the EEZ. So we've been focused, just because of logistics, pretty much all the talks from the US PIs at least have been focused on what we can measure in international water, all these air-sea interactions, and that's really interesting. But the forcing really comes from this big fresh water that comes from the big rivers up north, and the really salty water that comes from the salty Arabian Sea due to a lot of evaporation. And as all this circulation happens, pretty much all of it is inside these countries' EEZs that we don't necessarily have access to. But through the collaborations that we established over the last many years, now in India and also in Sri Lanka, we can start resolving these coastal circulations or a little bit more near coastal circulations. So really the goal of our projects since 2013, as part of a series, NASCAR and MISOBOB, have been to try to monitor these wind-driven circulation that you spin up and spin down every few months in the Bay of Bengal, and look at it not only at the surface, but also in the interior. So just to put this a little bit more into that context again, like we know the wind completely reverses and you generate these really big currents, exporting that fresh water from the Bay of Bengal or importing the Arabian seawater in and out. So these are just every couple of months the sea surface currents from VISO, from the satellite altimetry. And you see at the surface, there's a big seasonal changes, these circulations, but the big question is really what are the vertical structures of those currents? What are the water mass properties that are imported and exported? And all of this relates to these big questions we've been talking about for the last couple of days here. How do you modify those water masses? But here we're really focusing on those gateways and how these water masses happen. And as I mentioned a little bit earlier, none of this work can really happen without strong collaborations and really this two-way partnership that we established with our colleagues in Sri Lanka, our colleagues in India, our colleagues in the Maldives, and in the Seychelles. And this is just more than us, much more than just logistics. Together, we spend time in workshops like this discussing what are the important problems for both people here and also for the questions we're interested in, and also helping with the technical training. So we've done glider trainings here in India. We spend a lot of time in Sri Lanka working with the Samadruka and helping our colleagues there. And these are really gratifying and important, and that allows us to also look and get these wonderful data. So I think Craig will show this a little bit later, but this is sort of an overview of all the glider work, the sea glider work that we've done. Craig Lee and myself and our group have done in the last 5 years. A lot of it is kind of looking at that 8 north line that I'll describe in a little bit more detail. So that's our kind of Bay of Bengal sections going from the coast of Sri Lanka to a little bit inside the international water to moorings that NRL had. And really that big exchange sections, that's the ones that we've been focusing mostly in the last several years as part of NASCAR and MISOBOB to look at that exchange between the two bay, and some autonomous samplings as part of NASCAR supported by colleagues in the Seychelles and also in the Maldives. So these are, you see kind of long missions, and Lou talked quickly about adventures and stories. So you could probably imagine that many of those missions, and there are fun facts about mission being captured in Maldives Coast Guards, and a lot of people and a lot of help has been going into getting this. So this is really a testament to all the investment that many organizations and many people have done to really allow to collect this data. So focusing now on that these exchange sections. So since the end of 2013, really December 2013 and 14, we really spent a bunch of time kind of working out of Trincomalee on the northeast of Sri Lanka. And logistically, it's a little bit more challenging, but we were able to get something like 18 sections going back and forth and really getting kind of through a lot of the seasons, getting a good idea of how the exchanges happen, both really near the coast, which has not really been observed very well, and also all the way out, kind of close to where the southwest monsoon current comes in. And then more recently, again, we've been really successful at operating that line kind of right in that shipping lane that Lou was talking about. So we've lost a few vehicles and we've got some weird hits, but overall, still a very wonderful data set that I'm just going to show you a little bit more. So this is one typical glider section, it's kind of at 8 north. So this is an early one. And it's sort of towards the end of the southwest monsoon. So you get the southwest monsoon coming in, kind of going offshore. And as the monsoons kind of weans down, the Sri Lanka dome, which kind of like you see the remnant of that Sri Lankan dome, and Shurston has a good poster that kind of shows these evolution. So in this case, the Sri Lanka dome has been kind of pushed up north. So it's kind of up here. And you see kind of that nice, very salty Arabian seawater coming in. Red is big geostrophic velocity into the page, so going up north. And then near the coast of Sri Lanka, in those kind of a few kilometers, maybe 20, 30 kilometers, you get this really fresh water that is zooming south along the coast. And that's sort of a remnant of both the circulation of the Sri Lanka dome and also that East India coastal current. So you get that fresh water coming in. And there's a lot of structure. And you can imagine that if you start kind of putting all these sections, this is the kind of zooming out and looking at 18 sections at 8 north, kind of from the coast of Sri Lanka to the internal shallow water. Bluish, purplish is that fresh water. And you really get that idea that it's really, you see that nice, clean, fresh water at the surface and being advected, you can compute geostrophic velocity and start looking at the transports of those water masses. And there's a lot of filament. There's tons of recirculations. And I'll show you a few more transports idea later. But first, I just want to kind of go back to that southern section real quick. And really, in this case, we have now 30 sections. So this is kind of over 2 years or so. Red is a southwest monsoon, where you get that salty water, in this case, zooming towards the east. And then during the northeast monsoon, near the coast of Sri Lanka, here I switched. This is Sri Lanka here and going offshore. So this is north-south section. So you get fresh water going west, in this case, during the northwest monsoon. But what's really striking in this picture in particular is how small these little recirculation jets are. And it's a very highly modulated, and each of the sections take a few weeks to complete. But you get a lot of that variations and a lot of those filaments recirculating on top of that big kind of transports that you expect from kind of the aviso or that large-scale mean. This is kind of putting everything on one annual cycle, looking at both the 8 north and the exchange sections, 85 and 85. So here what I do, I kind of look at my entire sections and compute the net transport. And everything that's going west, everything that's going towards the Arabian Sea, carrying fresh water is kind of in blue, or everything that's carrying south in the 8 north section is carrying fresh water again is colored blue. And if I integrate the northward transport, that's in red in this case, and the eastward transport is red in this case. And you kind of see both of them add up to kind of what you expect during the northeast monsoons. You get that fresh water kind of exiting the Bay of Bengal. And then during a southwest monsoon, you get the Arabian Sea water kind of coming in, zooming in. So this is kind of that nice little southwest monsoon pictures. And you see that the annual, we didn't quite resolve the annual cycle as well in 8 north, mostly because of logistics. But you start seeing these interannual monsoons and that variations that's really interesting. Luca will talk a little bit about I imagine that Luca will talk a little bit more about these ideas, but with that data set, we can really start looking at water mass exchange and water mass modification, both within the Bay of Bengal and all these little filaments and recirculations that I'm talking about. So what I'm doing here, inspired by work from Arnold Gordon and others, is just looking at the Argo data set. In the last 5 years, there are several tens of thousands of profiles, and kind of looking at TS diagram and identifying that salty Arabian seawater, where it is in all of the Argo data, and that fresh Bay of Bengal water in different water mass characteristics, and kind of seeing how these water masses evolves and changes. And I can look in our exchange sections, at what is the volume transport of each of these different water masses. And that really emphasized, so this is kind of an example of that on that 80.5 east section, exchange sections. So here I'm tracking any water mass that has the characteristic of the Arabian Sea, how much of it is moving east or west along my sections, going from 5.5 to 2 north. And you see that it's not just that simple picture that I presented in mean. It's not all the Arabian seawater going one direction and all the fresh water from the Bay of Bengal going out. It's all these little recirculation coming in. Sometimes you get filaments of fresh water coming from the equator and kind of wrapping itself around. On average, you do get sort of that mean export of modified Bay of Bengal water. The very fresh water happens only very close to the coast of Sri Lanka, always going east. But you sort of start painting this picture of a complex spin-up circulation that is not just this mean, nice pictures that we have. And really that data set is, for the first time, gives you that long couple of or 5-year type of evolutions of how these different monsoon signals come and go. And all of this, as we know very well from the talks here, is modulated by these big inter-monsoon oscillations. So trying to look at these water mass property, how much of it is exchanged with the different basins in the context of these big process studies that we're doing is key in what we're doing. So I'll just conclude here basically by, again, emphasizing that these exchanges are quite a bit, are modulated by all these Rossby waves and these big oscillations that we're talking about, and we can resolve it. So all that data kind of goes very well in the context of these nice interior studies that we're talking about. And our goal in this meeting is really to see how all of this contributes a little bit more to the ship in the process studies that we're doing. Thank you.
Thank you. I think we have time for a question while the next speaker sets up. All right.